Hello viewers, welcome to the second lecture of the lecture series on data communication. Topic of today's lecture is layered architecture. Obviously, layered architecture for data communication. On completion of this lecture, the students will be able to explain the concepts of layering, explain the basic principles of the layered architecture, particularly of the OSI model. They will be also able to explain how information flows in a layered architecture and specify the functions of the 7 layers of the OSI model. The outline of today's lecture is as listed here. We shall first discuss why layered approach, what is layered approach, basic principles of layered approach, layers and interfaces, entity and protocols, services and service access points, types of services, service primitives, ISO's OSI reference model. ISO stands for International Standards Organization and OSI stands for Open System Interconnection. Then we shall discuss functions of different layers of the OSI model. First, let us start with the basic concepts, or why do we really need layered architecture. In the last lecture, we have discussed the basic issues of data communication. There we have seen that data communication is a very complex process. It involves many issues, many functions, and particularly when a user is trying to communicate with another user, then the user must send in a particular form by following a set of rules, so that he can communicate over a unreliable, error-prone communication system. As we know, the real world is not really ideal. It has got noises and many things can happen, attenuation, distortion, noise, these are the things will come. As a result, the data that we shall try to send will pass through the unreliable medium. So, the user wants to perform reliable communication through the unreliable, error-prone medium. And to do that, it must follow a common set of rules for generating data. And at the other end, the receiver must follow the same common set of rules for interpreting the messages. And unfortunately, it has been found that the set of rules to be followed is very complex. It is so complex that it cannot be considered as a single entity. It is not possible to implement as a single entity in a monolithic form. What is done in such circumstances? Normally, we follow a layered approach, and this layered approach provides a viable viable technique to deal with a complex problem. So, not only in the case of data communication, layered approach is followed in many applications. In this particular case, we shall follow the layered approach for data communication. And we shall see it will involve a large number of functions. The large number of functions will be grouped or partitions into a hierarchical set of layers. Essentially, this layered approach is nothing but a divide and conquer technique. What we do in a divide and conquer technique? A particular problem or task is divided into a number of subtasks such that each subtask can be tackled easily. So, let us see the basic issues or basic concepts of layered approach. First point is, as I said, a complex problem is divided into a number of pieces of manageable and comprehensible size. Normally, the data communication system is very complex. What we want? We want to divide it into pieces of manageable and comprehensible size, such that each task, each subtask or each piece can be managed, can be understood easily. We may consider it as a modular approach. We know that whenever we try to develop a software, if the software is complex, we try to divide into a modular approach or structured modular approach. What we do in that? We try to divide into modules, then each module is developed developed independently. That is precisely what we are trying to do here. So, it may be considered as a structured modular approach. One objective of this layered approach is that each module can be developed and tested independently. Why this is important? Normally, as we shall see, a data communication system is not implemented by one person, or as an example, an application software, a complex application software is not developed by a single person. It is usually developed by a team of people. Similarly, a data communication system is developed by a team of people having expertise in different areas. So, here what we are doing, we are dividing into modules such that each module can be developed and tested independently. Whenever it is done, when the development is performed by a team of people, we can assign a particular module to a particular person. He can develop it and test it independently. That is one basic principle, one of the basic principles of layered approach. Then another basic principle is, it allows easy enhancement and implementation of the functions of a particular layer without affecting other layers. That means, as we assign a particular layer to a particular team member, he will be able to enhance it, implement it independently. That means, subsequently if some modification is needed, some correction is needed, then that modification or enhancement can be performed independently without affecting other layers. And whenever we shall be doing layering, we have to follow some principles to do the layering, to do the partitioning. What is the first principle to be followed? First principle is, we have to use optimum number of layers. The number of layers into which the complex problem will be divided should not be too large, should not be too small. If it is too small, suppose a complex problem is divided into two subtasks, then what will happen? Each subtask will remain again of high complexity. What we want? We want to divide into some optimum number such that the subtask is not very difficult, not very complex, it is comprehensible, manageable and understandable. Then second principle that we have to follow is, put similar functions in the same layer. We shall see that the data communication functions can have, some of the functions are similar, some of the functions are dissimilar. What we want? We want to put similar functions into a particular layer, and other functions can be put in another layer. Then this layering can be considered also from another viewpoint, from the level of abstraction. As we are performing a hierarchical set of layers, we may consider that essentially we are dividing into different levels of abstraction. That means the topmost layer has the highest level of abstraction, and as we go down the layer, then it gets more and more refined, more and more defined, and then at the lowermost layer it becomes easy to implement. That means the abstraction level keeps on I mean that higher layer will have higher level of abstraction, and then the lower layers will have lower level of abstraction. And as I have already mentioned, the partitioning should be done such that the changes of functions in a particular layer can be made within a layer without affecting other layers. Then as we shall see, we have to create layer boundaries very judiciously. Why it is necessary to create layer boundaries? Because we shall see that the communication between layers will take place through the layer boundaries, and if the layer boundaries are not judiciously defined, then the communication may be problem, or communication information to be communicated. For example, we have to choose layer boundaries to minimize information flow across the boundaries. This is another objective or another principle to be followed while doing layering. Why it is necessary? You see, we are decomposing the data communication system into a number of layers. Now, it is somewhat similar to say multitasking, a particular task or parallel tasking. A particular task is divided into a number of parallel tasks or parallel processes. What we want in that situation is minimum inter-process communication. Here also what we want, the layer boundaries must be minimized in such a way. We have to minimize the information flow across the boundaries. That means the two layers which will communicate with each other through the boundaries, that information flow through these boundaries should be minimized. Then the system interconnection rules. Okay. Here as I was mentioning, we have to create layers and also the interfaces between layers. Then in such a case, we have to see that the system interconnection rules are modularized in terms of series of layers of a functions, say n layers. That means we shall divide the modules in the task into a number of n layers, and each layer will contain a group of related functions, and a layer below layer n and a layer above layer n are layer n minus 1 and layer n plus 1 respectively. So, we have to give names to the layers, so that the topmost layer will have the higher number, lowermost layer will have the number 1. Then between each pair of adjacent layers there is an interface, as I was telling, and the interface will define which primitive services the lower layer offers to the other layers. As we shall see, a lower layer will provide service to the upper layers. That means lower layer is a service provider and an upper layer is a service user, and layer n provides service to the layer n plus 1 through service access points. That means each layer will have a number of service access points. Through these service access points, layer n will provide services to layer n plus 1. And as we shall see, each layer will add value to the services provided by lower layers. That means from the lower layer, the services provided by layer n will be used by layer n plus 1 to add value. Let us take up let me explain with more details with the help of a diagram. Here is layer n, so let me explain with the help of this diagram. So this is layer 1, and this is layer 1 of another side. So this is a user A and this is user B, and this is layer 2, this is layer 2, this is layer n, and here is layer n. So we have grouped into n layers, and we can, as we can see, there is layer boundary here or interface. Layer 1 has an interface with layer 2 of this user of this system. Here also you have interface between layer 1 and layer 2. Then layer n has interface with layer n minus 1, layer n has interface with layer n minus 1, layer 2 has interface with layer 3, and layer 2 on this side also has interface with layer 3. So here we have got n layers on two sides. Then here is the interface boundaries between layers. So this is the interface boundary between layer 1 and 2, interface between boundary between layer 2 and 3, and here is the interface boundary between layer n minus 1 and n. And the, as we shall see, the communication take place through a physical medium. Here is your physical medium, through which ultimately communication will take place, and layer 1 will interface with the physical medium, and communication will take place in this manner. And each layer will have some protocols, and this is known as layer n protocol, layer n protocol. As we shall explain in more details what do we really mean by protocol, and here for example is layer 1 protocol. So here I have drawn the diagram of two sides of two systems. Say here is user A, here is user B. As you can see, the data communication system has got n layers. Here data communication system has n layers, which are communicating with each other through a physical medium. This is the basic concepts of layers and interfaces. Now data communication occurs between two entities in different systems. We have seen that the different layers are there, and within each layer there are some entities, and entities are responsible for communication. You may be asking, what is an entity? Entity is essentially an active element. An entity is something which is capable of sending, processing or receiving information. An entity can be a piece of hardware, entity can be a piece of software, or entity can be a piece of hardware software combination. and these entities will communicate, entity of layer n will communicate with entity of layer n of the other side. So, the entities will be communicating, these active elements within the layer is an entity, and they are capable of sending, processing and receiving information. And for communication to take place, the entities should follow an agreed upon protocol. For example, if two persons wants to communicate, they should use this, they should use the same language. If one person is speaking in Bengali, another person is speaking in English, cannot communicate with each other. They should follow some agreed upon rules which are known as protocol. So, for communication to take place, the entities should follow an agreed upon protocol. Here we have the details about the entity and protocol. As I mentioned, a protocol is a set of rules that govern the data communication. It defines what, how and when. So, the protocol will define what to communicate, the communication, that information to be communicated, how, in what form it will go, in the form of a byte, in the form of a 1 kilobytes of packet, or say 1 page of book. So, it will decide that, and how it will be communicated, and also it will define when to communicate. And for that purpose, we have to define the syntax, semantics and timing. Syntax is, it will refer to the structure of format of the data. The data has to be properly formatted, so that the other side can interpret it properly. Then you have to follow, you have to follow also semantic, the way the bit patterns are interpreted and actions taken based on the interpretation. Semantics is nothing but some kind of grammar. For example, a language has a grammar. Semantics is that kind of a grammar, or the way the interpretation of the data has to be done. So, you have to define the syntax and semantics. Then the timing is very important for communication. It will specify when data can be sent and how fast it can be sent. As we shall go into the details, we shall see that there will be need for synchronization. That means, when a data is sent, then the other side has to receive it from that point, so that it receives correct data, and also there will be some specific rate of communication. That means, how fast it can be sent, that has to be decided. So, the rate of communication will be part of the timing. Let me explain how the layers communicate with each other through service access points, and for that purpose let us consider two adjacent layers. Here you have got two adjacent layers. Say this is layer n and this is layer n minus 1. Okay, instead of writing on this side, let me write on the other side. So, this is say layer n and this is layer n minus 1. Now, here you have, and this is the interface between the two layers. And these interface, there is some service access points. These points are the service access points. SAP stands for service access points. So, through these service access points, the layer n entities will access service, get service from layer n minus 1. So, obviously, the service access points will have some address, will have address. It is somewhat like, let me give an example for this. Suppose we are using telephone system, that socket of the telephone system is the service access point of the telephone network, and as we know, each socket corresponds to a telephone number, and that is the address of that service access point. So, if I want to use the telephone network for data communication, my handset has to be connected to the socket, and then I can get the services of the telephone system. So, here is somewhat like that, this is the service provider and this is the service user, and to get service from the service provider, the layer N will send some data known as it has got two parts. It has got two parts. One is your interface data unit ICI and the SDU service data unit. SDU stands for service data unit and ICI stands for interface communication. ICI stands for your interface data IDU, IDI, not the ICI, interface data unit, ID, sorry, it is ICI. Interface control information. Let me erase this part. This is actually ICI. ICI actually is interface control information. And SDU is service data unit. What this, and this is communicated to the service access point and for communication to the lower layer. So, interface communication control information is not really the data, it provides some control information to the lower layer. For example, whenever you are writing program in assembly language, there is some assembly directive. So, that is a directive to the assembler, for example, ORG, EQ, DB, these are the assembly directives. So, with these are not really the instruction, but some directive to the assembler. Here also somewhat similar to that, the layer N will send this particular data, this is called the PDU or protocol data unit of this layer, this is communicated to the lower layer. And this lower layer will separate it out, ICI is separated out from the SDU, service data unit. Then the SDU can be divided into several parts. For example, here there is one part and it will be included, that SDU will be included in that into another some kind of protocol data unit, we call it protocol data unit PDU, which will, and this layer n-1 will add some header to it. So, after receiving this protocol data unit from the n layer through the service access point, layer n-1 will separate out the interface control information, take out the service data unit, put it in another protocol data unit. This is essentially protocol data unit corresponding to layer n-1. It will add some header, then again it may send to the next layer through service access points. So, this is how the two adjacent layers, layer n and layer n-1, can communicate through service access points, and this is the essentially the unit of communication is protocol data unit. that protocol data unit is passed on through the interface to the lower layer, which is interpreted with the help of the interface control information. It takes out the service data unit, and again it makes another protocol data unit by adding the service data unit along with a header that can be communicated to the next layer. So, this is how the service access point works. And as we shall see, layer n of one machine carries on conversation with layer n of another machine. As I mentioned, although we are using layering, the entities of a particular layer of the same layer will communicate with each other, and the rules and convention used in these conversations are collectively known as layer n protocol. As I wrote in the diagram I had already shown, and the list of protocols used by certain system is called protocol stack. So, whenever the protocol is simple, it can be written by a single protocol, but sometimes you have to follow a set of protocols or a list of protocols, and that entire thing is known as protocol stack. This is the protocol stack. And the set of layers and protocols in the network is the network architecture. Our topic of lecture was network architecture, but I did not define architecture. So, here you see the set of layers and protocols is the network architecture. And as I mentioned, architecture is a set of rules and conventions that is used to build something. Let me define more precisely what do you really mean by architecture. It is a set of rules and conventions necessary for building something. It does not specify implementation details. For example, when we say Roman architecture or Gothic architecture, we usually refer to some stylistic pattern of a building. It does not say how it has been implemented, those details are not known. Essentially, it is a model, and the model can be considered as a framework of standard, and a standard based on model. Actually, an architecture will provide a framework of standard based on which something can be implemented. As we shall see, this network architecture will not really give you the implementation details. It will provide a framework of standard which can be followed, which can be used to implement something. Now, as I mentioned, the essentially different layers will interact with each other through the interface boundaries, then the lower layer will provide service to its upper layer. Let us see what are the different types of services offered. Services can be connection oriented or connectionless. Connections oriented service is modeled after the telephone system. We are all of us know the telephone system. If you want to talk to somebody through a telephone system, first of all you have to set up a link, set up the connection. If you do not get connection because of some problem, no communication can take place. In other words, no data transfer can be performed without setting a connection. Only after setting a connection, then data communication can be done. So, it is connection oriented. Then connectionless model is, it is modeled after postal system. In a postal system we have seen, if we want to send a letter to somebody, we do not establish a connection with the receiver. We put the letter in an envelope, write down the address, and then put that letter in a letter box. Then the letter, from the letter box, postman collects it puts it in a bag, sends it to the distant place. There also another postman will open it. By looking at the address, he will deliver it. So, it can be connection oriented or connectionless. Later on we shall have examples of the connection oriented and connectionless services used in different applications. Then the services can have some, we can have some quality of service. Quality of service can be in different forms. One is confirmed service, another is unconfirmed service. That means we may want that a particular, for example, we are sending a letter. Then after sending a letter, if we want to know whether it has been delivered to the destination properly, then it has to be confirmed service. Sometimes that, for example, whenever we send a letter with registered acknowledged mail. That means we have to use that acknowledgement card, and after receiving that acknowledgement, we know that means that particular packet or letter has been delivered to the destination. So, in such a case, we shall call it confirmed service. On the other hand, normally we just post a letter and we assume that it will be delivered to the receiver, but there are situations when it is not done or there is some long delay. So, that can happen in an unconfirmed service. And as we shall see, there is as part of the quality of service, there are some other points like order of delivery. What do you really mean by order? Suppose we are sending 3 letters one after the other, or say we are sending 3 volumes of a book one after the other. First we send the volume 1, then we send volume 2, then we send volume 3. If it is not, it may so happen that at the other end it is not received in the same order. It may be that volume 3 may be received first, then volume 1 or volume 2. In such a case, there may be some problem. So, sometimes it is necessary to maintain proper order of service. So, order of service is important in the order in which things are delivered. Second is whether an error has occurred while sending the data. That means we have to find out whether any error occurred or did not occur. Then third issue is, which is part of the quality of service, is the delay. How much delay that is occurring in delivering the thing. So, these are the various quality of services needed which are used as part of the service. Let us take some examples of services. I have taken up 6 examples. First one is sequence of pages to be sent to another site. Another example is remote login, with which we are very much familiar with. Third one is digitized voice. The first three can be considered as connection oriented. And next 3 are connectionless. Example of connectionless service. Sequence of pages, remote login and digital voice is used, these are sent through connection oriented services. And this sequence of pages, whenever we send, usually it is a reliable message stream. Whenever we are sending reliable message stream, it is a reliable part of reliable service. Remote logging is also reliable byte stream we are sending, that is the service that we use. Digitized voice is unreliable connection oriented service that we normally use. Electronic junk mail is uses unreliable datagram service, that is connectionless. Another name of connectionless is datagram service. Then registered mail is essentially acknowledged datagram service, as I explained earlier in details. Registered mail, whenever we are sending a registered mail, and in database query, whenever we do, it is essentially request reply service. So, we have some examples of services provided in data communication systems. Now, here is the whenever service is provided, particularly connection oriented, then there are some service primitive. One service primitive is connection request. A request is made, that with the help of the connect request, the one side of the system requests a connection to be established. The other side will indicate whether connection, with the help of signal, whether the connection has been done. It will signal the called party that connection has been done. Then the connection response used by the callee to accept or reject calls. That means, the other side will have some indication. By having that indication, that other side will respond and will say whether it wants to accept or reject calls, then connect confirm, tell the caller whether the call was accepted. Then you have got data request, data indication, disconnect request and disconnect indication. These are the service primitives that is used, that has to be used in connection oriented service. Let me explain with the help of a time sequence diagram how it really occurs. Say so, this side is say system A and this side is system B. And here protocol actions are performed, and obviously this is the service provider. So, system A will make a request, say connect request, and in this direction you have got the time. So, after some time the other side will get some indication. So, here you get connect, indicate. Then this side, the system B side will send the connect response. And after some delay, the other side will receive this connect confirm. As an example, you can consider the telephone system. The system A, for example, system A wants to communicate. So, he will do it will dial the number, and the other side will get the ringing tone, that is the connect indicate. And after hearing the ringing tone as connect indicate, the user will respond by lifting the handset, that is your connect response, and the other side will get the information that connection has been confirmed once the system B side lifts the telephone. This side will know that the telephone has been lifted, and after that the data the data exchange can take place in the same manner. That means, data request will come from this side, then it will have some data indication on the other side, then data indication will be on the other side, then the data response will come from this side to this side, then it will have the data confirm, and after the data communication is performed in this way, then it will be disconnect request and disconnect confirm. So, in this way, in a in a sequence of time, by using this protocol, the communication will take place. So, we have discussed about the concept of layering, we have discussed the concept of interface, the interface the interface access points through which the communication take place between two layers. We have also discussed some services and some service primitives. Let me explain with the help of an example of a layered architecture. The most popular layered architecture that is used, that is most followed in data communication is International Standards Organization's Open System Interconnection Architecture. It is known as OSI reference model. As you can see, it has got 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. So, we see it has got 7 layers, and out of these 7 layers, the lower 3 layers are the responsibility of the network, and the upper layers are essentially the responsibility of the host or the computer. So, here you see the with the help of these 7 layers, data communication is performed, and most of the data communication systems follow this particular model. Let me start with the lowermost layer, functions of the lowermost layer, that is the physical layer. The physical layer is concerned with transmission of raw bits over a communication channel. As we have seen, the physical layer is connected to the medium, transmission medium. So, this physical layer is concerned with the transmission of raw bits over a communication channel. It decides the mechanical interface that has to be performed between two systems, that means the connector that will be used, how many pins it will have, what will be the length and so on. Then it will have signal electrical part, the signal levels, data rate, and so on, electrical part. Then it will have functional and procedural part, and also it will decide whether simultaneous transmission is in both direction possible or not, like simplex, we shall discuss in detail later, simplex or full duplex. These things we shall discuss more in detail later on. Then it also, the lower layer also decides how the establishing and breaking of connection. So, this is one of the functions of the physical layer, and it deals with the physical transmission medium. That means, what particular type of medium to be used, whether it will be we shall be using a guided media like coaxial cable, optical fiber, or we shall be using air, unguided media. So, these are all decided as part of the physical layer. Let me explain with the help of a diagram how the physical layer will communicate. Suppose this is one side of the physical layer. So, here you have got the one side, say suppose you are sending 0 1 0 0 1 1 0 0. So, this particular data, it is a raw bit stream, is sent through a physical medium to the other side. This side, the other side will receive the same thing. So, it will receive 0 1 0 0 1100. So, this side will receive the data. So, we can see here this is the physical layer. I have shown the physical layers, and these two physical layers are communicating through a physical media. And here is the raw bit stream. Then you have got the next layer, that is your data link layer. Data link layer, the functions of the data link layer, this layer transforms the physical layer to a reliable transmission and reception of structured stream. See, the raw stream is transformed into reliable transmission and reception of a structured stream, and here are the functions performed: framing, physical addressing, synchronization, error control, flow control, and also it decides whether the transmission will be character oriented or bit oriented. And as we shall see, whenever the communication is taking place where to a multiple number of people, then it will do medium access control. That means a medium is shared by a large number of people. Then we have got network layer. This is the functions performed in the network layer. Network layer is responsible for source to destination delivery by establishing, maintaining and terminating connections, and it will deal with logical addressing. As we shall see, as part of the frame we have to put source address, destination address. So, you have to do some kind of framing, and logical address will be part of that. Then it has to do routing, because here it will go through a number of systems, communication systems, and it can be done. There are examples of routing, virtual circuit, datagram service, as I have explained. It will do assembly and disassembly of messages. Messages may be assigned priorities, and it may be necessary to do internetworking, particularly in a heterogeneous network. That will be the responsibility of the network layer. Then comes the transport layer. This transport layer is responsible for true end-to-end communication. The previous one, this network layer, was not really concerned with end-to-end communication, but here this transport layer is concerned with end-to-end communication, particularly the quality of services required by the session layer is provided by this, the upper layer is provided by it. It will do port addressing, which we shall discuss later on in detail. It may be necessary to multiplexes end user addresses onto network. It may be necessary to break down a packet into a number of packets and reassemble at the other side. So, this segmentation and reassembly is done by this transport layer. Then the connection control, it monitors the quality of services, end-to-end error detection and recovery, multiplexing, flow control. These are the various functions performed in the network layer. Then comes the next higher layer, session layer. So, session layer establishes connection, and when the data transfer is complete, it does the termination. So, it performs dialogue management, and as part of the dialogue management, it will decide who will speak, when somebody will speak, and how long will speak. And as I mentioned, the communication can be simplex, half duplex or full duplex, which we shall discuss in detail later on. Now, whenever the communication is taking place over a long distance, there may be failure. So, to recover from failure in a efficient manner, some checkpointing will be done, and this is part of the session layer. It will also do the token management. This is necessary when some critical operations are performed by one side. So, the side which has the token will do the will perform the critical operation, and that management is done in the session layer. Then comes the presentation layer. In the presentation layer is responsible for syntax and semantics of information. For example, what is the types of data used, for example, whether it is say 2's complement number, or whenever we are using say floating point number, you have to use say IEEE 754. So, what data types are supported, this is decided. Then the character codes like ASCII or something else. It will also decide perform data compression, at the other side decompression like JPEG, MPEG, these compressions are done which is part of this presentation layer. Sometimes for secured communication, encryption and decryption has to be done, and this is the function of this presentation layer. Finally, comes the last layer, that is your application layer. Application layer is concerned with user applications, and there are two types: common application service elements like login, password checks, or it can be specific application service elements like file transfer, access management, access and management, job transfer and manipulation, electronic mail, video text, teletext, telefax, etc., message handling, document transfer. These are the this is the application layer, and this diagram shows rather gives in a nutshell the complete picture of communication. Here you see from application layer some data is coming, that data then application layer puts a header to it and sends it to the presentation layer. Presentation layer in turn will put a header to it, send it to the next layer, transport layer. Transport layer will put a header to it, send to the network layer. Network layer will put a header to it, send to the data link layer. And data link layer will send it to the physical layer, and physical layer will perform the communication. So, here how the communication takes place is maintained. However, the communication takes place between two users, rather peer protocols. For example, here you have got the user A, say here is user A and here is user A, user B. Suppose they are sending email. So, this user A will send email, and that it will go down to this channel and it will reach the user B. So, essentially user A is communicating with user B, and these are the layers which are used to pass the information through different layers, so that it reaches the other side in proper form and it is interpreted properly. So, before I conclude this lecture, let me give you some review questions. First question is, why is it necessary to have layering in a network? How do adjacent layers communicate in a layered network? Third question is, what are the key functions of data link layer? These questions will be answered in the next lecture. Thank you.